All right, chapter 2, where we talk about trade-offs, comparative advantage, and the market system. So we have 3 sections for this chapter, and I'm going to kind of divide this video, I think, into 3 parts, one for each one. So first we want to talk about production possibilities frontier and opportunity cost. Then we'll move on to comparative advantage and then the market system in general. So this is a slide, we talked about this one in chapter 1, that households, firms, governments always face scarcity, and so they have to make these decisions about how best to use their scarce resource. And because there's not enough time, not enough money, not enough any resource, a firm or a household or a government has to face trade-offs. And so we talked about that last time. We also talked about opportunity cost is the value of what you had to give up. Because I decided to do A, B was my next best choice, and so the value of B is my opportunity cost. And we talked about no such thing as a free lunch and all that kind of stuff. So that's just a little review. The production possibilities frontier is the first of the models that we will use, and this model represents that opportunity cost. That's kind of what it shows us. So there's lots of examples in your book, but it shows us the maximum attainable combination of 2 goods and service. So this is, again, one of those examples of a simplifying assumption. We assume you have 2 options. Now, we know you have more than 2 options, but we take your top 2, okay? So let's say you have 2 different things that you can do with your free time, okay? Your 2 favorite things to do are sleep and watch TV, okay? So there's always a scarce resource, and we're going to assume that your scarce resource is your free time, and that you have 5 hours, okay? So there's always something that is scarce. In this case, it's your time, all right? So if you spend all 5 of your free hours sleeping, you will have 0 hours left to watch TV. If you sleep for 4 hours, you have 1 hour to watch TV. Sleep for 3 hours, you can watch TV for 2 hours. 2 hours sleeping gives you 3 hours to watch TV. 1 hour sleeping gives you 4 hours, and if you don't sleep at all, you can watch TV for 5 hours, okay? Now, obviously, there are other things you could do with your time, but we're saying these are the 2 things that give you the most benefit, all right? The most enjoyment in this case. So if we were going to graph those, the first of our many, many graphs, so this is 0, okay? So we're just doing the upper right quadrant. And so let's say this is sleeping, and this is TV, and we do 1, 2, 3, 4, 5. This would look a lot better if you had graph paper. 1, 2, 3, 4, 5. I'm trying to get those about the same. Oops. Sorry about that. 4, 5. So if we plot each of these points, so point A here would be 5 sleep and 0 TV. That would be right here. The next point would be 4 sleep and 1 TV. So that'd be right here. Then we have 3 and 2, 2 and 3, 1 and 4, and 0 and 5. So these would be these 5 points we have right here. So if we connect the dots, pretend like those are on the line here. Let's see if we can draw that a little bit better. If we connect the dots, we have a straight line that looks like this. This shows us all the combinations of sleeping and TV, all the ways we could use this 5 hours. It could be 2.5 and 2.5, right? It doesn't have to be 1 hour increments. But that's what this shows us. So any point on this curve is what we call an efficient use of the resource. So we're also assuming that an hour of sleep gives you the exact same amount of enjoyment as an hour of watching TV. You like them both the same, okay? So anything on this point is efficient because it maximizes your enjoyment. If you spent 2 hours sleeping and 2 hours watching TV and then 2 hours folding your laundry, that doesn't give you as much enjoyment, so that doesn't maximize your enjoyment. So we'll say in this respect that's not as efficient. if let's say you wanted to, let's say you spent 2 hours, let's say you did that. You spent 2 hours watching TV and 2 hours sleeping. So that's right here, okay? And then you spent the other hour, let's not use something productive. Let's use it, you spent it on Instagram, okay? You were just scrolling through Instagram or watching TikTok videos or whatever, and it's something you enjoy, but not as much as sleeping or watching TV. So we'll call this inefficient because it doesn't give you as much total enjoyment as one of these points along the curve would be, okay? So it gives you a little bit less enjoyment than your other two options. Also, let's say you wanted to spend 3 hours watching TV and 3 hours sleeping. Well, that puts you out here, and that is unattainable with the current resources. That's 6 hours, and you only have 5 hours. So that's unattainable with the current resources. The only way to get that is if you got more time. So let's say you skip class or did something else you weren't supposed to get yourself an extra hour of free time. That's the only way that one would be possible. But with our current constraint here of 5 hours, that point is not possible. Now, this is an example out of the book, and this shows a plant for Tesla, and they can produce sedans or SUVs. And so these are the 5 points, very similar to the ones we just did. And if we graph them, they look like this, okay? They can produce 80 sedans or 80 SUVs or some combination of the two. And so any point on here is efficient. If they decided to produce 30 sedans and 10 SUVs right here, that would be inefficient. They would have leftover capacity. And so that's not an efficient use of the resource. This combination right here, which would be 60 and 50, is not attainable with the current resources. They don't have, even if they were running 24/7, they cannot produce that combination. So that one is unattainable, and this one, F, is inefficient here. So it shows us what they can do. It also shows us what they would have to give up, okay? So let's say they are currently producing here at point B, okay? So they are making 60 sedans and 20 SUVs. If they want to make 20 more SUVs, okay, they want to go from 20 to 40, that would move them to this point, and so they would have to give up 20 sedans to do it. In order to gain 20 SUVs, they would have to give up 20 sedans in order to do that. That's the opportunity cost. So the opportunity cost of producing 20 more SUVs is 20 fewer sedans. In order to get this 20 increase here, they had to give up 20 sedans. So the production possibilities frontier shows us what they're capable of, but it also shows us the opportunity cost and the trade-offs that they would have to produce. So in this case, again, we've got this nice straight line. So it kind of assumes that the resources needed to produce one are similar to the other. It would even maybe assume that the profit in one is similar to the one the other. But more often than not, instead of this nice straight line, like we had with the TV and the sleeping or this one, we have a curve line which represents increasing opportunity costs, okay? So in this example, we're producing automobiles and tanks, okay? And if we're starting out here at point A, okay, so and we're starting at point A, so we are producing 400 tanks and 0 automobiles. In order to move from A to B, we want to increase our automobiles by 200, okay? So in order to do that, 200 automobiles is what we gain, okay, that's our plus. What do we have to give up to do it? We went from A to B, so we only had to give up 50 tanks. So 200 automobiles cost us 50 tanks in terms of production. So you would look at that and go, oh, well, that's I gain a lot, and I only had to give up a little bit. But if I move from point B to C, okay, from B to C, so again, I gained 200 automobiles. But what did it cost me this time? When I went from B to C, right here, it cost me 150 tanks. Cost 150 tanks. So you got the same gain, 200 automobiles, but now it costs you 150 tanks instead of 50. That's what we mean by increase in opportunity cost, and that's often what we will see here. One of the really important concepts in macro is economic growth. So this represents economic growth. Remember we said, so if we're looking at this curve right here, this first one, right here, point B is unattainable, right? We cannot produce 450 automobiles and 300 tanks. But if we can push that production possibilities frontier out like this, we can get that. If we can increase our resources. So there's a couple different ways to do this. One of them is maybe we build another plant, and so now we're capable of producing more automobiles and tanks. We have better technology. That's a big one for us to increase our production possibilities frontier, that we can produce more automobiles and tanks in the same amount of time. So we become more technologically advanced and we can produce more with the same resources. Sometimes, in this example, the economic growth affects both of them equally, but sometimes it looks like this, okay? So this one is a technological change, and we're going to talk a lot about this concept right here, this economic growth, and how we can produce more tanks without having to give up automobiles, or the other way around. And getting more resources is one way, but technological change, since we're already pretty developed, technological change is the #1 way for us to do that. So it becomes very, very important to economic growth. And we're going to talk about economic growth in a couple chapters about why that is so important to the economy. And so what drives that, especially for us, is going to be, there's a couple different things, but a lot of it is technology for us. So in this case, the technology affects automobile production, but it doesn't affect tanks. However, it still allows us to, in this case, it changes the whole shape of the curve, but it does allow us to move out like this, so we can get more automobiles without having to give up any tanks. So that's still, the total production is still greater. We didn't have to trade. We were able to produce more of one without the other. So even if the technology doesn't affect both of them, it can still push that production possibilities front out and change the shape of it there a little bit. So let's just do kind of a quick review. In this one here, it says use this production possibilities frontier to answer the following questions. Which points are unattainable? So in this case, that's E, that's right out here beyond the curve. So that one is unattainable with the current resources. Which points are efficient? So anything on the curve is efficient. So that's B, C, and D. And which one's inefficient? That's A. That's inside the curve, so that is inefficient. We're not producing as much as we can. Now, here's my favorite part of this question. At which point is the country's future growth rate likely to be the highest? Now, to look at this, so we can say B, C, and D are all technologically efficient. We cannot say which one of those points is better. Remember, we talked about technological efficiency and allocative efficiency. So the PPF curve can show you all of these points are technologically efficient, but they can't tell you which one's allocatively efficient or which one's better, okay? Now, if we look capital goods, these are things related to manufacturing, property, plant, equipment, technology, that kind of stuff. And then consumption goods are, consumer goods, things that consumers are going to produce. So at which point is the future growth rate likely to be higher? And we haven't talked a little bit about this, but if we're just producing consumer goods, those are not things that are aimed at our long-run growth. But capital, things that are going to increase our production in the long run, make us more efficient in the long run. If we go back to this guy, capital goods are things that are going to push that production possibilities frontier out. So more technology, more property, plant, equipment, those types of things. So point B right here with more capital goods is going to give us a higher growth rate in the future, because that's made up of those things that lead to that growth rate. Now, does that mean that's the best point? No. It just means it's going to yield a higher growth rate, but you're doing so at the cost of consumption goods. So as a society, you might say, well, this one's going to yield us higher growth rates, but we need to keep our people happy too, so we're going to come down here or maybe here, something like that, and split the difference. So while we can't say one's better, we can, again, go back to that cause and effect. If we do this, here's what's going to happen. If we go up here, it's going to yield a higher growth rate. If we go down here, it's going to slow down our growth rate, but maybe keep your people happy in the long run, or at least in the short run. So capital goods are kind of aimed at a long-term thing, consumption at a short-term thing. And I'm going to do one more here. This is, I believe, in your homework. So, and you might have a different version of this problem in your homework, but the process is the same. So the first question says, if Ford uses all its resources to produce trucks, how many can it produce? So here's cars and here's trucks. If we do 0 cars and do nothing but trucks, we follow that all the way up and we go right here. Oops. So we could produce 10,000 trucks. Suppose they are currently building 3,000 cars per day. So if we take 3,000 and we follow that up, we end up right here. I'll call this point A. And at point A, we are producing 3,000 cars and 9,000 trucks. All right? Like that. To build an additional 1,000 cars, how many fewer trucks can be built? So they want an additional 1,000 cars, so that would put me here to 4. So I'm going to follow that up, so that would put me here. I'll call this point B. So point B would be 4,000 cars and 7,000 trucks. So how many fewer trucks? That's 2,000. So the opportunity cost of 1,000 cars is 2,000 trucks. According to the graph, building 3,000 cars and 4,000 trucks. So 3,000 cars and 4,000 trucks, that would put me right here. So I'll call that point C. And what is that? That is inefficient. Oops, efficient. Because that is below my production possibilities frontier curve. So anything under the curve means I'm not utilizing all my resources.